So in summary, you have a lot of tools at your disposal, and we'll be experimenting and using them throughout the course when it comes to visualizing data. And I just remind you that to decide what to use and even what package you may want to use in Python, it really depends on what goal you are trying to meet in the process of creating the visualization. Let's end with a practice question. So I'm actually going to have you fill out this table on the left, basically now looking at all the possible types of visualizations we've discussed in this class and put them into which box they fit. And some may fit in more than one category, but see if you can best fit each of these based on what you've learned in these series of videos. Okay, so let's go through solutions. So for distributions are going to be the case when I have just one feature. For quantitative distributions, we've talked about histograms, talked about violin plots, talked about density curves, and box plots. Those will be the key tools that we're using in this class. For qualitative distributions, we actually only gave us one option, which was a bar chart. And in particular, I chose C instead of A in this example because if I'm doing a distribution, then my y-axis needs to be either counts or proportions, frequencies. It can't be another variable, right? So A is going to come into play later, but it's not an example of visualizing one qualitative feature. Now, if we have two quantitative, typically we'll start with scatterplot. And then if we realize that we have a functional relationship, so if there's some variable where each input only has one output, then we can plot that as the independent variable and connect the points with a line graph. If I have issues, say, of overplotting, or if one of my variables on this axis here only has a few discrete values, then side-by-side box plots is a great way to compare to quantitative features. So here I have discrete quantitative values on the x-axis, and then I'm plotting the distributions on them for each scenario. So that's J. If I have two qualitative features, then we talked about both the idea of either the side-by-side bar chart or the overlaid line graphs. Those are great options. And then one quantitative and one qualitative, I actually have the most options for. So bar chart would work here because, again, here I have qualitative on my X, quantitative on my Y. I can also do side-by-side box plots. I'm saying J and I here in the sense that, just do side-by-side box plots, not I quite yet. So I'm saying J. In theory, what I would mean is this axis here in X would be your quantitative. Nope, backwards. This axis in X would be your qualitative, right? So your categories. So that would be why J would work. And then I, you can do a scatter plot exactly like we're showing here. And so I would say that as long as you don't have much overplotting, this is probably a good way to go because it helps to give you a sense of the number of data points involved. If you have a bunch of overplotting, I would go with side-by-side box plots. The one thing to be wary of is sometimes you'll have a lot of data points for, let's say, this category, this category, this category, and then maybe my last category only has like 2 data points and it has a very bizarre looking box plot. So I would be careful with doing side-by-side box plots if you have some sparse data. You may want to keep that information by keeping the scatter plot. We're going to see that later in the course when we look at our project. Okay, so then, yes, side-by-side box plots here. L, and then M, side-by-side violin plots. Overlaid density curves, again, can be a great option. Overlaid histograms can work depending on if you can see the data clearly. Oh, and I guess I put N twice, so we already know about N. So this gives you lots of tools at your disposal for visualizing data in this class.